Hi, it's me again. I'm going to talk to you a little bit today about chemical reactions. So there's some pictures here, and all of these pictures are showing something that is a chemical reaction. You did some reading about it before with Ms. Longebach. You talked about it with Mr. English, I believe. And so here we have rusting, and we have burning, and we have decomposition or oxidation. And those are all examples of chemical reactions. But before we get on to that, I want to go over our answers from yesterday. So when you did that PhET simulation yesterday, you should have played with all those different states of matter and seen the differences between solid, liquid, and gas in water and then in another element. So here's just what you should have come up with. So the starting temperature of water as a solid is negative 127 on the simulation. It actually freezes at 0, but at negative 127 is what they had on the simulation. And you should have noted as you cool, the solid temperature decreases and the molecules move more slowly. What happens as you heat the solid? The molecules start moving faster and they start moving apart because they're turning into a liquid. Next, you're going to select the liquid phase, and that was at 13 degrees Celsius. And you should have noticed that the molecules spread out and fill up the bottom of the container, and they move around more. They seem to flow. What happens as you cool the liquid? Well, as you cool it, then the molecules are going to start to slow down again, and they're going to start to clump together because they're going to start freezing and becoming a solid. What happens as you heat it? As you heat it, they move faster and they start spreading apart. And if you heat it enough, then it's going to turn into a gas. And that's what number 7 says, select the gas phase. So you should have seen it started at 156 degrees Celsius, which it actually starts turning into water vapor at 100 degrees Celsius. The water molecules are moving faster and they're floating all around the container. They bounce off the walls and into each other. What happens as you cool the gas? The molecules slow down again, and if you get the temperature below 100 degrees Celsius, then they fall back to the bottom because they have started to change into a liquid again. What happens when you heat up the gas? The molecules speed up, they spread farther apart, and they bounce off of each other more because they're just filling up that container because they have no shape and no volume. And then you were to choose another element to use and do the same simulations. Tell me what element you experimented with and explain some of the differences. So I chose neon, and I noticed that it started out a lot colder as a solid. It had a more definite shape than water. It was like a perfect square. When I heated it up, it turned into a gas really easily. It was only a liquid for a really small range of temperatures. That makes sense because I know that neon is a gas at room temperature. So if you have seen neon signs that are like bright colored, then you know that neon is a gas. So it's not usually a solid or a liquid. It's a gas when we see it. Okay, so that was from yesterday, and let's go on to learn about today. Okay, so we're talking about chemical reactions, and those are different than physical changes. Prior to this, we've just been talking about something melting or freezing. And that's just a physical change because it still stays the same thing. Like when you melt water, when you melt ice, it's still water. When you boil water, it's still water. But we're going to start talking about chemical reactions or chemical changes, and that's when you make a totally new substance. So matter can also change by going through a chemical reaction, and if this happens, you get all new substances. How are physical changes different from chemical ones? So physical changes, like I said, are when the composition is changed, but not the substance. So like phase changes, like melting or boiling, cutting or breaking something, dissolving something. So they're still what they were before, but they might just look different. So now we're going to move on to chemical changes. So a chemical reaction is one when we get new substances and the matter is totally changed. So the atoms have bonds between them that are holding them together. They break and they form new bonds with other molecules, and it makes a whole new substance. And the way that you can tell if you have a chemical reaction are by these instances. So you might see a change in color. You might see a change in texture or hardness. You might see that energy has been released. Energy is absorbed, like it feels colder. You might see smoke, you might see gas or bubbles, and you might form a precipitate. That's like a solid that forms in your liquid. I'll show you some examples of that in just a second. So, where do these chemical reactions take place? They can take place anywhere that bonds are breaking and reforming. So, in the universe, on a bike, in your bodies, constantly in your bodies, in a plant that's growing. These chemical reactions are taking place everywhere. Here's some examples. Some of them absorb energy, like when you cook food. Some of them release energy, like when there's heat or light or fire or even a sound explosion. Some of them happen quickly, like this rocket taking off, and some take years and years, like rust forming on this bike. It's not going to happen immediately if you leave your bike out and it's foggy. Eventually, after a few years, then you might see the rust starting to deposit on it. So here's an example of a reaction, and the way that you can tell the reaction is happening is you're going to see a gas forming or bubbles. And this is a common one. I'm sure you guys have done it before, vinegar and baking soda. But when you combine vinegar and baking soda, then you don't have them anymore after the reaction is done. You are left with something totally new. So let's watch this. This is Mr. English.
All right, how's it going, Lancers? Mr. English here. So I have 20 grams of baking soda and 20 grams of white vinegar, and the vinegar is temperature right now is 20.5 or 20.6 degrees Celsius, right in between. And you can see on my kitchen scale here, two substances separate weigh 40 grams, and I'm going to go ahead and start the chemical reaction. Okay, all right. Make sure I don't lose any. I lost a little bit. It's on the scale. We'll see if this works. A gram of carbon dioxide gas was released. And some other indicators that we've created a new substance would be the bubbles. You can see it continues to bubble. We may even lose another gram of carbon dioxide gas. The temperature of the new substance is 17.4 degrees Celsius. So you can see that we can confirm that a chemical reaction took place because we have a change in temperature and we have a change in mass. Where did that mass go? Carbon dioxide gas.
Okay, so we saw in that demonstration that two reasons that we know a chemical reaction happened. Number one is we saw the bubbles forming, and that shows that a gas was coming off. And number two, we saw that the temperature changed of the reaction. So it started off as 20 degrees, and then when it was done, it was only 17 degrees. So those are two indicators that we know a chemical reaction has occurred. These are some terms that you're going to need to put into your notebook on page C2 and C3. So you have chemical reaction, which is any change in matter that produces one or more new substances. You have reactants. Those are the substances that begin the chemical equation. So those are like the ingredients. And then you have your products, and those are the results that the substances that result from the chemical reaction. So that's what you end up with. So you can pause that if you need to copy those down. When you're ready, I'm going to show you one more example of a chemical reaction so that you can see that it has happened. So let's watch this. Here's another example of being able to tell that a chemical reaction has occurred. So you can see there's two different chemicals in there. He has one in a beaker and one in a test tube. And when he mixed them together, you saw the color change, and then you can also see it gets cloudy. And so two things have happened there. You see a change in color that tells you a chemical reaction occurred, and you see a precipitate formed, which is like a solid or a powder that comes from the liquid. If you remember, we did that in the lab, in the limestone lab, where you blew the carbon dioxide into the lime water and you got a precipitate. So that's an example of a chemical reaction. There is going to be a Google form today to see what you learned about chemical reactions and how you can tell they've occurred. So you're just going to turn that into me today. If you have any questions, please reach out.